Hello, I am Shayak Pal with my fellow team member Omolajit Nandi. We are presenting our project Build My City VR under the guidance of Dr. Professor Tanima Bhomik for the IEEE Future Tech Explorer Challenge 2026. So, we are addressing a massive gap in India's school curriculum under the National Education Policy 2020, which is the lack of experiential immersive learning platforms for urban planning and climate action. Setting up a hardware heavy VR costs over 5 lakh rupees per school, which is completely unfeasible for most institutions. Our solution is Build My City VR, which is a lightweight WebXR app designed to run under any browser with a $15,000 basic PC setup. Looking at our screen, here is a desktop dashboard. In the header bar, there is an Enter VR button in the top bar, allowing users to enter the virtual reality. Next is the India map panel, where Chennai, Delhi, Bengaluru, and Kolkata have pulsing markers. Chennai, Dehradun, Bengaluru, and Mumbai have pulsing markers on our leaflet panel. Clicking on Chennai loads the coastal port and its regional modifiers. So our city stats dashboard have 6 live budget matrices, which is budget, population, happiness, pollution, and resilience. To design our city, we use the build panel where 12 plus building types are available, such as residential, archaeology, water hub, metro line, and solar farms. We build directly on our 6 by 6 city grid, placing buildings across 6 by 6 grids. We also have a policy checklist with 5 policy toggles, such as public transport and waste management. Activating public transport increases citizen happiness. Under our event log panel, trigger events like cyclone alert or an economic boom. We use progress such as turn control panel. Pressing the advanced turn button simulates 1 year. There is also an undo button to revert mistakes. So behind the scenes, we calculate the city state. During iteration 1, our metric calculations had a bug where happiness dropped instantly to 0 under storm events. In iteration 3, we corrected the formula to balance trade-offs and create a education planning model and not a physical simulation. We corrected the code to ensure that it ran perfectly on every tile change to recalculate budget, distribution, and emission scales. The desktop features a parallax background. It is a glass morphism UI with a parallax effect where the moving the cursor moves the background. We also have 2 new components found, which are ambient knobs and background elements, and an interactive analytic grid. The centralized state object keeps data in sync between the VR and desktop dashboard. It sends the updates to the 2D dashboard whenever a change happens in the VR, while the event deck system uses the function to trigger random events in both modes, such as cyclones and heat waves. Finally, the assessment report enables teachers to download an assessment report as a PDF. We have tested this tool in class 9 students at a Kendriya Vidyalaya in Tamil Nadu. Build My City PR can scale up to serve India's 26 crore school students, making climate action planning accessible to every classroom. Now, Amulajit will present the immersive VR scene.
I am Amulyajit Nandi. I will now demonstrate immersive WebXR mode through a screen recording of my headset session. So as I have chosen Chennai Coastal Port, now I am entering the VR interface. So through the maximizing it, we can access it, and then we will click on to the enter VR start exploring button. And as here we can see that this is the tactical view HUD dashboard, and this is the VR build palette dashboard, where these all are the elements of this VR interface section. Through exploring, we can compute each of the elements in the plot of this smart city section. As here we have chosen the residential ecology. Now I am choosing the water hub section as the part of the smart city. And as we can see that if I will here navigate the industry zone in the plot, as much as we the weather of this area is getting in danger. That means pollution is getting increased, so that the sky color is getting red shaded to define as the pollution level is in high. The changes we can see in that section. Now here also, as we can see that the pollution is getting increased. Like now it is 59, and if we will here plot more, then it will get updated. It is not getting updated because it is out of the budget. As we can see now here, my budget is fixed. So here I have the rest of my budget is $75, and the cost of the industry zone is $165. So I can't purchase it. As thus the simulation will work over here, and all these are at the different viewpoints. From here we can also visualize the entire plot area. This is the visuals, and here this is the city operations visuals, where as we have chosen the area Chennai Coastal Port, and this is the turn one, and all the budget, revenue, clean energy, pollution are showing in the this dashboard. And this is the mission intelligence board. We can visualize this play from here. Now let's get an eye on that. So over here all the active goal and whatever the target will be, it will be specified over here. As the simulation will getting work over here, so we can visualize the changes also from the website section. Like we have implemented the industry zone here, as it is mentioning as IN, and the residential portion for RS. So as the simulation will getting work like this, our motive is to guarantee comfort on low-end hardware, so that with the performance optimizers maintains 72 fps using the intersection observer. And overall, by bridging the desktop, dashboard, and WebXR, we make climate education both affordable and engaging for Indian students. Our engineering process is like that, defining the NEP like 2020 problem and ideate WebXR solution, and then iterate with student feedback, so that with optimized performance and the instant feedback loops, we impose kids to see the immediate consequences of their planning choices. So thank you IEEE for giving me this opportunity to demonstrate my project for our increasing India. Thank you.